You guys are my first geometry of the day, by the way, so try to remind me to record. When I start talking, just be like, did you record? Because I forget all the time, but I'll try to remember. Okay, similar polygons. Looks like this. The first thing that we're going to talk about is a ratio. Have you heard of a ratio before? Algebra, probably. You talked about ratios quite a bit. A ratio is just a comparison of two different numbers. So you can see it a lot of different ways. Sometimes we write it like this, A to B. Sometimes we write it like this, A to B. Or we can write it A to B. But every one of them is said this way, A to B. Okay, it's a comparison of those two numbers, A to B, and A to B. When we're working with ratios, we are always, any guesses, going to do two things. If I have a number like this, what do you suppose we want to do with that number? Simplify. We are always going to reduce, and we're always going to use the same what? Guesses? Same what? Not denominator. This one's tricky because I didn't give you any of these. We're going to use the same units. So if one is feet and one is inches, we're not going to say 3 feet to 6 inches. We're going to say 36 inches to 6 inches, right? We're going to compare them using the same units. Okay, so reduce those fractions, reduce the ratio, and use the same units. Okay, so here's your first example of this. It says a pygmy rattlesnake averages 18 inches. A western diamondback averages 5 feet 6 inches. What is the ratio of the length of a pygmy rattlesnake to the length of a western diamondback? Okay, order matters, right? So the way they ask the question, what is the ratio of a pygmy rattlesnake to a western diamondback? That means pygmy on top, diamondback on bottom, right? Put them in the order you're given. So if we're going to do that, first of all, we know the pygmy is 18 inches. And typically I write it the fraction way. You're welcome to write it a different way. That's fine. But the way I will always do it for you is in that like fraction form. The other one, 5 feet 6 inches, would be there. Okay. That's not pretty. How can I turn that into a ratio of their lengths, a real comparison of their lengths? Will you tell me your name? Kai.
Turn feet into inches.
We're going to turn the feet into inches, yes. So we want everything in the same units. So 5 feet 6 inches, first of all, let's just do what he said. This is how many inches? 60 inches. 5 times 12 inches in a foot is going to be 60, right? So I have 6 inches here, 60 inches for the 5 feet. So it's 18 inches to 66 inches. Okay, so now we have the same units. That's great. We want to do what with those numbers? Reduce. We're going to reduce those. So 18 over 66 would reduce to what? Do you see a number? 3 over 11. If you divide both of them by 6, 18 divided by 6 is 3. 66 divided by 6 is 11. So 3 to 11 would be the ratio of pygmy rattlesnake to western diamondback, okay? So you can write it like this. You can write it like this if you like that better. That's up to you. Questions on that? So same units, make sure you reduce. Moving on. Example 2 here, it says the measure of 2 complementary angles. Impress me. What are complementary angles? 2 angles, not 3, not 5, 2 angles that add up to 90 degrees, right? So the measure of 2 complementary angles are in the ratio 1 to 3. What are the measures of those angles? Here is my suggestion to you. Whenever they give you a ratio and we have to solve for some missing piece, take a variable and attach it to those 2 pieces. So call this 1x and call this 3x, okay? We don't know what that x is right now, but that's what we're trying to find, what the relationship between them is. We know the relationship. We know it's a 1-to-3 ratio. We need to figure out what is the missing piece. So if I have 1x and 3x for my ratio, how could I set this up to figure out the measure of the angles? Luke.
4x equals 90.
Right, we're gonna add them together. So the two angles, 1x and 3x added together should equal a 90-degree angle. So we get 4x equals 90. We're gonna divide by 4. So x comes out to, what is that? 22.5. Is that our answer? The question was, what are the measures of the angles? So what is the first angle, the smaller angle, going to be? 22.5. This is one angle, right? This 3x is the other angle. So if I just plug a x in there, angle 1 is going to be 22.5 degrees. What's the second angle? Yep, plug it in here. 3 times 22.5 will be my second angle. And when we do that, we get 67.5 degrees. How can you check your work? If we add those together, they should equal what? 90. And they do, so we're pretty solid that we're in a good spot there. Questions on that? Copper.
Why do you add the 1 and the 3 together?
So it says the measure of two complementary angles. So that right there should tell you if I add those two angles together, they should equal 90, right? So I'm going to take those two angles, the 1x and the 3x, I'm going to add them together and set them equal to 90 degrees. Does that make sense?
So you want to just have 3x equals 90?
4x, because we have the 1x for the 1 part of it, right? The ratio is 1-to-3. So this angle plus that angle. So the 1x plus the 3x will give us the 90 degrees. Yeah. Any other questions on that? All right. There is, oh yeah.
So it's saying that like it takes up, so there's a 4 part and one angle is smaller than the other angle?
It's 2 parts, right? A 1-to-3 ratio. So it's comparing 2 angles right now. One has a proportion of 1 part of it, and then there's 3 parts of it, right? A 1-to-3. So the 1x and the 3x added together is what we're looking for. Yeah. Sometimes there's what's called an extended ratio, and you can do an extended ratio for as many pieces, parts as you want. This shows 3 numbers being compared. You can't write that in the fraction form, so that one they'll always write in the like colon setup. But just know that you can compare lots and lots of different things. It's just however many numbers they give you in your setup. So that would be an extended ratio. This problem gives you an extended ratio. It says the lengths of the sides of a triangle are in the extended ratio of 2-to-4-to-5. The perimeter is 77 inches. What's a perimeter?
All the sides added up.
All the sides added up. Okay, they just told us the ratio of the sides. What are we going to do with that 2 and 4 and 5? Add a variable to it, right? We're going to attach an x behind each one of those. So call this 2x, call this 4x, call this 5x. Okay, it says what's the length of the longest side of our triangle? So we have some work to do to get there. What are we going to do first? Add them together, 2x plus 4x plus 5x, and set that equal to what? 77. That's our perimeter. Okay, so when we do that, we get 11x equals 77. So let's divide by 11, and we get x is 7. The question is, what is the length of the longest side? What right now is representing your longest side? 5x. right? You have a 2 to 4 to 5. Your biggest number is going to represent the longest side. So what is the length of your longest side? 35. You take that 5x, and we're just going to drop the 7 in. So 5 times 7 is 35 what? Inches. And guys, I'm pretty picky on units. Make sure you label. 35 inches and 35 feet are very different things, very different lengths. So label what you know. That'll help a ton. Okay. Questions on that? Okay. Moving right along. Proportion. You've talked about proportions before. You've done a lot with proportions in Algebra 1. A proportion is just an equation that states two ratios are what? Proportion might look like this, right? They are equal. You put an equal sign between them, it's a proportion. So that two ratios are equal is a proportion, okay? Now with proportions, there's different parts. There is what we call the extremes of proportion. Not that I want to talk politics, but if you get political, right, there's some extreme political views. There's the extremely conservative versus the extremely liberal, right? Those are extremes, like when they're on the far ends. That's how you need to think of this. The extremes of a proportion are where you started and where you ended. They're on the far ends. So your extremes of proportion would be here and here. Okay, so in this setup, it would be A and it would be D, your first one and your last one. Then there's what we call the means of proportion. And if you think about mean, like if you go back to mean, median, and mode, remember learning about those? What was another word? No? Who said no? You did, I promise. You learned it. What was another word for the mean? Do you remember? Starts with an A. It's the average, okay? So the means of proportion is the middle. It's kind of the average. It's what's in the middle, right? So your middle two numbers, your means of proportion would be the B and the C in this one, okay? We don't do a ton with the terminology of that, but there is a relationship that you're going to see. We're going to talk about it right now with cross-multiplying the means and the extremes, and we'll get into like geometric mean eventually, and it'll all make sense. But we are going to just briefly talk cross-multiplying because you do some of that right now. You've done this before. When you cross-multiply, when you take a proportion and we need to solve for one of those variables, we just cross-multiply. So we multiply A times D, right? And we set that equal to B times C. Okay, that's this, AD equals BC. Just be careful with that, because I feel like a lot of people, it's like, well, duh, I knew that. And sometimes people think, well, duh, I knew that, and then they do weird things with it because it's like so easy, I guess, that they're not really thinking about what's going on. So just take your time when you cross multiply, make sure you're multiplying, setting equal, multiplying, okay? So let's try that, just to make sure that you're all good here. Letter A. If I want to solve for the variable, what am I multiplying? Kai. Oh, is that not a hand?
Weren't you 6 and 4?
Yep, so you're going to go 6 times 4 equals 5 times x, okay? So 24 equals 5x, and we're going to divide by 5. And we get x equals, that comes out to 4.8. Okay, now you could always check this. If you were to plug 4.8 back in here and then plug into your calculator, 6 divided by 4.8 and then 5 divided by 4, those two numbers should be the same, right? We're saying they're equal to each other. Make sure they actually are equal. Okay? Questions on that? Yep, Copper. Because we had 24 equals 5 times x, right? We're trying to solve for x. So to get the x by itself, we have to do the opposite and just divide. So that's just going back to the algebra. Okay, one other of these. This one's a little bit fancier, not terribly, but we'll see if you know what to do with this. Any thoughts what needs to happen now that there's that expression up top, that y plus 3? What do you got to do with that? Is Kai going to give me all my answers today? I start calling on other people.
You do the y times the 6 and the 3 times the 6.
Good. Yeah, we're going to distribute, right? Which means we need parentheses. So we're going to just put parentheses around this and say 6 times y plus 3 equals, so that's this way, right? Now we're going to cross the other way, 12 times 5. Okay. And then from there, you can do some simplifying. So if we distribute this, you get 6y plus 18. 12 times 5 is, how's your mental math? 60. Guys, I was playing cards with my family over Christmas, and they're always like, Brooke's the math teacher, she'll keep score. My mental math over Christmas break is like out the window. It is just gone. I can't do it. So it might take me a minute to get back into it again. But it's okay. Hopefully it's taking everyone a minute and I'm not just lagging behind. We are going to keep solving here. Take away 18. So you get 6y equals 42. And then divide by 6. What's 42 divided by 6? Good job. So y is 7. And again, you can always plug it in to double check. If I plug a 7 in up here, I get 10 over 12. And 10 over 12 does reduce to 5 over 6. So we know we've got the right answer. Questions on that? Okay. Last thing. And this last thing is kind of a lifesaver a lot of the time for people because you can actually do it wrong and get the right answer, which people love, right? It's awesome when you can do something wrong and get the right answer. Not that I'm encouraging that, but just know you have a little bit of a buffer when it comes to problems like this. So with proportions, there are 3 different properties that you're going to see show up. I feel like most of the time, these are the 2 that we're going to focus on. This one doesn't show up too terrible much, but I'm going to teach it to you regardless, just so that you know them all. So with proportions, let's say we start with this first one that says A over B equals C over D. Okay? The properties of proportions are beautiful in that they say you could actually take the reciprocals of both of your ratios and you will still have an equal proportion. So basically flip them over, put B over A and D over C, and they are still equal to each other. Okay, so that's the first one. You can take the reciprocals of both. You cannot just flip one and not the other. That won't work. But if you flip both, they're still equal, okay? The second property of proportions says you can actually switch your means, your B and your C. So notice we just moved the C to the bottom, the B to the top, left our A and D in the same spot. They're still equal. Think about it. If I cross multiply this, I get AD equals BC. If I cross multiply this, I get AD equals BC, right? It's the same thing. So you can actually swap those numbers and you'll still get an equal setup. And then the last one basically says if I started with this, A over B equals C over D, if I take the numerator and add the denominator to it and make that my new numerator over the original denominator and do it on both sides, I will still get equal proportions. So basically we're saying the top number plus the bottom number over the bottom number, the top number plus the bottom number over the bottom number. So any of those properties will work at any time with any proportion, which is why sometimes people like rearrange things and do it wrong and they still get it right. Hooray. Excuse me. Okay, so last problem here. Says, one second. In this diagram, x over 10, right? That's this, x over 10 equals y over 9. what ratio completes the equal proportion? So if I say x over 10 equals y over 9, then x over y should equal what? 10 over 9. Do you notice what just happened? We took our means and we just swapped them, right? So if it's x over y, then it's got to be 10 over 9. Okay? What if I said 9 over y? What would that have to equal?
10 over x.
10 over x. So that would be if we just flipped them, right? Took the reciprocals. So the relationship is always there. It's just a matter of, are we flipping them? Are we switching numbers? You may not just flip one and leave the other. That's not going to go well. But any of those properties can be applied in any setup. Any questions on that? All right.